Good morning, everyone. Like Lisa mentioned, I'm the head of urban analytics at Esri. And what that means is, prior to, I was the chief analytics officer in New York City, and we thought about how to use data and data science to solve really complex problems in New York City. And the way I talk about my role in New York City is that we were a no-cost analytics consulting firm to the mayor. So that meant anytime there was an issue or a challenge that the mayor felt like data and analytics could be brought to bear to partner with the other agencies in the city, my office would get called in. And so what we did was ultimately design sort of patterns, best practices, and strategies around how we were able to maximize our helpfulness in the city. And now I take those patterns and those designs and those strategies, and I work with cities around the world, cities domestic to the United States, to help implement those strategies, and we drive thought leadership. So today, we drive thought leadership in this space. So today what I want to do is share with you guys sort of how we took the Mayor's Office of Data Analytics, which we were affectionately referred to as MODA, from a small team of about 3 or 4, and we were doing one-off projects, but we ultimately grew into this urban analytics team, a team of civic intelligence strategies that used urban analytics to solve problems. So we really sort of became more thoughtful. We were doing one-off projects, and we became more thoughtful. And I'm going to sort of walk you through that process. And through that process, I'm going to share some interesting stories and case studies of the work that we did. So I want to start from the end, which is, what is urban analytics? And urban analytics is what we ultimately defined in the city as our strategy, right? And urban analytics combines the use of location intelligence, data science, and urban data in order to assist decision makers in realizing powerful outcomes in cities and organizations. So the way you want to think about it is, there's a space before policy where you can drive operational efficiency that ultimately drives policy. There's a space during policy where you can help to execute successful policy decisions or make policy decisions more successful. And then there's after policy, and so when policy has been executed, how to ultimately make policy better. Because we always say, at least in New York City, and I wonder if you guys say the same things here, which is, you know, we, in New York City, we try to legislate good quality of life, and that's really very difficult to legislate quality of life. And so we, as MODA, play a role in executing operationally to help drive policy. So there's 4 core principles to urban analytics. The first one is helping to make cities' operations more efficient. So it's operational. And what I mean by urban analytics is used for operational efficiency, I'll just briefly explain as to what it's not, right? It's not research analytics. It's not put together a report and tell me about something. Or it's not performance analytics, which is your city stats and comp stats and things like that, where you're counting the performance capability and you're driving performance through numbers. It's not performance analytics, it's operational, and it works with operational agencies to allow for them to do their job in a more efficient and capable manner. Second is, you have to drive with quantifiable success in mind, meaning you always have to baseline when you come in. So whenever we got pulled into an effort, we always asked, how successful have you guys been doing this? Because the idea is that the city has always been attempting and driving this operational capability. So the question is, what have you been doing? And then now when we bring data and analytics in, the idea is to understand, did we drive success in that space, or did we not? And if we did, how much more successful and quantifiably were we? Because that's the only way we showed our value. Our value came in being able to show that we were able to drive cost recovery through working with agencies. Then the next is identify the city's data ecosystem, which I'll talk about in the next slide. And then lastly, we think about with urban analytics transparency of big data analysis. Now that's very important is because what we do at MODA is we codify essentially public policy in code, right? In data science algorithms, in machine learning algorithms are representative of the city's policy. And it's called public policy, not private policy. So therefore, there has to be some level of transparency into the tools and the algorithms that we're building. So that's also a key tenet of urban analytics. So here's the city's data ecosystem. And we spend a lot of time, day in and day out, maximizing our ability to understand this ecosystem and essentially to drive it. So if I start from the top left, day in and day out, there are things happening in the city that create data about the city. Whether your Department of Sanitation is picking up garbage every single day, they're generating information about their routes and about what they've done, right? Or whether police officers are making arrests or driving enforcement in certain areas, data is being generated about what they do. Or whether you have people who are enjoying the community, the lake and so on and so forth, and they're tweeting about what they're experiencing. That's data that's being created about the city. So then once people who are using the city, living, playing, eating, working, and so on and so forth in the city, they create the data about the city. Once you combine that data with models that represent the city, and those models can be 3D models, geospatial models, data science machine learning models, any type of model that represents the city, once you combine the data with those models, you create knowledge and insight about the city. And that knowledge and insight then is used by city leadership and the community and citizens in the community to then better interact with the city, right? And that ecosystem iterates day in and day out. I'll give you a very brief example. In New York City, long time ago, we didn't really have bike paths. And what we found was that cyclists who were getting to and from work, because there's all sorts of taxi cabs and cars, and the city is overcrowded with folks driving, cyclists were getting into accidents all the time. And so they complained, right? And so what someone in New York City did was, the city leadership did was map where these accidents were taking place. So you take data about the city, and then you put it on your geospatial model, so you map where these accidents are happening, where they're likely to happen, where congestion takes place, and so on and so forth. Then you also map based on time, rush hour, and so on and so forth. So now you know where a lot of these cyclists are getting hit and running into all sorts of issues with traffic. So then what happened was that was shared with city leadership, and city leadership said, okay, let's invest in bike paths in specific areas in New York City. So now you have bike paths. So they shifted the city based on the data and the model that represented a certain piece of what was happening in the city. And now you have cyclists riding in the bike paths, and so now you have some level of people are more likely to ride their bikes to work. And so maybe you can count and see emissions going down in New York City. Maybe traffic is letting up because less people are riding their bikes, and so on and so forth. So you see how using data against the model of the city allows for people to interact with the city and drive the city, and so on and so forth. So that's just a simple example of this data ecosystem that you have to spend a lot of time thinking about and defining. So let's, these are really clear and standard sense of what we think about when we think about smart cities, right? Resilient, safe, livable, prosperous, equitable, sustainable, well-run, healthy. But from an urban analytics standpoint, it's not just about identifying what those are, because driving towards a smart city is just that, right? It's a process. It's not a destination. And so when you think about the process, you really think about what do you need in order to execute on that process. You need to have precision and accuracy. You need to be cost effective. It has to be timely. Things in cities happen in shorter spurts than in federal and state government, so you have to be timely. Collaboration is key, transparency, equity, right? And so you also need to identify analytics patterns. And so that's what we saw over time. Over the 4 years that I was in New York City, we began to see consistent patterns that popped up over and over again, meaning the types of questions we were asked. You know, find the needle in a haystack, find something. You'll see in a quick example of that. Where to go first, how to prioritize certain things. In New York City, we have, you may have heard about it or read about it, we have a big rat problem in New York City. And you get people calling in all over the place and talking and complaining about the rats and so on and so forth. And so there's a challenge of, well, where to respond first, prioritization, scenario analysis. One quick example of scenario analysis was, we have a Vision Zero initiative in New York City, which means we want to drive down pedestrian deaths through accidents with cars to zero over a period of time. So when Mayor de Blasio came into office, and I noticed here in Australia, there's not many jaywalkers. That's not like a thing here, which is really stressful for a New Yorker to kind of sit at the red light and wait to cross. But we noticed that there were a lot of pedestrian deaths from people jaywalking in New York City, because that's pretty normal in New York City. Well, the mayor came to my office and said, hey, can you do a scenario analysis of if the police officers actually began to enforce, because police officers don't stop people from jaywalking in New York City. They don't make arrests and fines. They don't do that. So, but what if we did? What if we enforced that? Would we drive accidents, you know, and pedestrian deaths down? We did an analysis, and what we found out was, if you enforced jaywalking in some of the more densely populated areas in New York City, you actually would not have enough space on the sidewalk for people to walk. So we couldn't do that. So we continued jaywalking, which I'm sure made a lot of people happy. Cost estimation, matching resources. Here's a problem. What sort of resources do we have available to apply towards that problem, right? Using a scalpel instead of a sledgehammer, method of solving problems. Anomaly detection, what's different? What do we see different, right? And so you can always have some combination of these, and then there are others that need to be identified. These were some of the key ones that we identified in New York City. So let me share with you sort of this journey. When I started in 2014, in 2012, New York City was hit with a superstorm, Sandy, hurricane. And madness ensued. After we got out of the end of that, Mayor Bloomberg at the time, the mayor at the time, commissioned an after-action report. And in that after-action report, he stated, we're going to create this Mayor's Office of Data and Analytics, and their job is to regularly collect data and reporting about essential city services, including electricity, fuel, and telecommunications. And do a lot of other things as well. There was a lot of mentions in terms of recommendations in this after-action report of what the Mayor's Office of Data Analytics would do. Newspaper articles picked up on that and began to say, here's what this new office should do. And so when I started in 2014, everyone had a sense of what we should do. But one of the key things that everyone knew needed to happen was we needed to understand and have more information about the city. One of the things you may have or may not have heard about of the side effects of Sandy was that there was a fuel shortage in Sandy, because we didn't know how much fuel we had in reserves and where we were going to get it from. And because there was so much flooding, we couldn't get more fuel in, and we ran out of fuel, so much so that license plates with an even number could only get gas on certain days, and license plates that ended in an odd number could only get gas on certain days. You can imagine, New Yorkers, we're not normally, on good days, very nice people. So you can imagine how crazy it got. And so we knew we needed to know more about the city in terms of data. So the first thing I did was come in and look to connect all of the systems. So I worked with our Esri partners in New York City and look to connect all of the GIS systems, because I knew, even though I was the mayor, the head of the Mayor's Office for Data and Analytics, I knew GIS data was the key component of what was going to be mostly important to us, because everything in the city happens somewhere, right? So we connected all of these, and it allowed for us to, so I knew there was 3 things that we needed to do. We needed to invest in technology, we needed to get people on board, and this is the people side, get all of the agencies on board to use the technology, and then we needed to invest in process. And process was data drills, and so we tested offline, not actual emergencies, but we created scenarios of emergencies and brought all of these people together to use that integrated GIS and data environment to help solve scenarios. So one of the scenarios was a blackout scenario. And so we simulated a blackout that happened in a certain area of Brooklyn, New York, and all of these agencies had to come together over the course of 2 days to answer one question. See, when it comes to data and analytics, there is always a question that city leadership are asking. City leadership doesn't say, hey, listen, Amin and Moda, there's a problem, go solve it. No, they have a question, and the question here was, how many elevators are down and can we quickly route emergency vehicles to the needed locations? That was the question, and it was a big science of where question, right? So the first thing we did, we mapped visually, this is a visual view of all of the working elevators in all of the buildings that have working elevators in the city of New York. Working meaning there's some elevators that are down and so on and so forth. And so we got a sense of what elevators were down before the blackout and what elevators were down because of the blackout. So we had, one, this geospatial view. Next, we had a view of all of the buildings that were actually affected by the blackout. So you see how we're sort of triangulating into the challenge here. Next, in New York City, we have 311, which is a non-emergency number that you can call for sort of non-emergency, well, not non-emergency, but non-death related sort of emergencies. So if we assume if people get stuck in an elevator, they'll likely text or call 311. Also, in those locations where we felt like the blackout would affect where elevators were, we put a geofence around those locations such that we can trap tweets coming from those particular areas, because we know people are more likely to tweet that they're stuck in an elevator than go onto a government site and tell us that they're stuck in an elevator. Right? So we were capturing tweets in that area as well. And so this is just a data drill by the numbers, but basically we did over 11 trainings over 3 weeks, and then we did a 2-day data drill for this one. When we completed this effort, one of the senior advisors to the mayor was a part of this, and you see that all of the different types of people, it just wasn't GIS people that were a part of these data drills. It was policy people, it was IT people, it was urban planning, it was everyone. And one of the mayor's senior advisors was in this effort. He told the mayor called me to his office and said, I heard about this data drill. I want you to do a data drill a month. So for about 2.5 years, up until I left to come to Esri, we do data drills on a consistent basis. And we get better and smarter at thinking about how we share data and solve problems in New York City. So this is just feedback and evaluation. You know, easy access to data and awareness of what other agencies are doing is one quote. Or the exercise allowed us to explore other agencies' data that may be useful for our own agency. That's key. It's a very important thing for agencies to, agencies know how to use their own data to solve their own problems. What's really next level is using other agencies' data as well to help you solve your problems. And so one of the challenges that came about was that we saw was that being able to integrate data across agencies, because you have in New York City about 11 agencies who store data about buildings. And each one of those agencies stores different data. Some of it is the same, but different data about buildings. And so what we decided, and we saw that in this data drill, and so what we decided to do in our integrated platform, our citywide intelligence platform, was to integrate data across 11 agencies to get one 360-degree view of New York City's buildings. And so let me show you really quick a demo of that. And so essentially, this is a 3D view of all of New York City. I can put in any New York City address, and I can click on any building. And when I click on that building, you notice it's pulling the data at the time that I click on the building. And on this left-hand side is showing you all of the data that we have with regards to that building that's coming from multiple sources in that citywide intelligence platform view that I showed you. And here's a more extensive view of all of the data about that building. All right, so there's a little error here. So this goes to, so this is actually a New York City. I'm going to have to call someone in New York City and let them know that it's down. This actually goes to these are all open New York City portals that New York City currently uses that we built. And so this is all of the information, is lifestyle information and everything else. Now going back to the slides, we got called into an emergency in the summer of 2015. The ultimate numbers were 12 dead, 127 infected from spray, water coming from cooling towers. Department of Health went in and they figured out cooling towers are these cooling apparatus that sit on top of buildings. So we had this citywide building, 360-degree view of buildings in the city. And what we immediately knew in order to help solve that problem, so the first thing that the mayor asked, I was at this press conference, and a bunch of commissioners who run agencies, we had a big meeting prior to this press conference, and the first question that the mayor asked is, what is a cooling tower? Right? We had to answer that question. The second is, where are all of the cooling towers in New York City? And there's over, can anybody, I'm just going to do this really quickly, can anybody throw out a number of how many buildings there are in New York City? Just a quick number, a guess. Loud, a little bit louder. Who said a million? Yeah, it's exactly right. There's a million buildings. Where you got Google over there? So there's a million buildings in New York City. So we had to find every single cooling tower. We used the Building Intelligence Toolkit, and all of the data that was really impressive. So all of the data, I didn't even know there was a million buildings until I had to look it up. We used all of the data that we compiled through this model to identify the first set of data that helped us find where cooling towers was. What we found out, and Lisa alluded to this, what we found out is if you own a building in New York City and you have a cooling tower on top of it, you can actually apply for a tax write-off. And so what we figured out from the data that we were compiling was that Department of Finance has data about buildings that have cooling towers on it because the building's owners would apply through Department of Finance for a tax write-off. So once we got that information, we built machine learning models, supervised models, to identify other buildings very similar to the ones we found in the Department of Finance database. So again, City Hall has a big question. Where are all of the commercial cooling tower systems in New York City? The data and analytics team has a question. How do we use data and analytics to help canvassing crews more efficiently target buildings that are likely to have cooling towers? So again, data science and the science of where and location intelligence, without it, there was a 1 in 10 chance of us sending a canvasser to a building that had a cooling tower. With location intelligence and data science and urban data, there was an 8 in 10 chance. Remember I said one of the key tenets of urban analytics is quantifiable success. So even in an emergency, we went in and said, how have you guys been doing? What have you guys been doing? Tell us the benchmark so that we know if we're helping. Because if we're not helping, then we'll just need to get out of there. Multi-step solution. Use machine learning, distribute a strategic subset of entities, supply canvassing support with routing algorithms, manage incoming data, and then refine the model and the target list, and we did that for 3 weeks straight. Another case study. So that one was looking for a needle in a haystack. Remember our analytics patterns? Looking for a needle in a haystack. This one, most New York City elementary schools are violating Disabilities Acts. So we got sued by the federal government, Department of Justice, because we were violating, they said we were violating ADA because it was taking longer for students with disabilities to get to school than it would for students without disabilities, which is a clear violation of the Americans with Disabilities Act. So the mayor's lawyers came to my office and said, we have to respond to DOJ in 2 weeks, which means you've got 1 week to tell us through data. So they actually said, tell us through data that that's not the case, right? Prove otherwise. We actually went through the data. We got data from Department of Education, and what we saw was that it looks like it actually is taking longer. But what we also did, we reconciled that data against mobility data. So we know students use smartphones. So we partnered with the private sector, brought data in through the citywide intelligence platform. It's not just for public sector entities to share, it's also a mechanism for private sector to share data. And what we did is, if you can share the demo. So what we did is, we actually used mobility data to see, I'll show you. You can click on any school, and what it'll do is identify the routes that they take home, and then show you, this is real data, real-time data that we got from mobility companies that are tracking in an anonymized fashion students traveling from schools and the directions that they go, right? And so we reconcile this against what we had, and the answer is absolutely, it's taking a longer time for students with disabilities to get home than it is for students without disabilities. Back to the slides. And so what we saw, but that wasn't the solution, right? That wasn't the solution. The solution was, what we figured out using location intelligence was that this was happening only in certain districts, and even within certain districts, only at certain schools. So we went back to DOJ and said, listen, we'll fix the areas that we know are not in compliance, and you get off our backs. Nah, we didn't say it that way, obviously. But if we do that, will you let us be? And this is New York Times articles that basically says, inaccurately characterizes the number and geographic distribution of accessible schools. So we said, hey, you're actually saying the whole city is in violation, the whole city isn't. Geographically, the whole city isn't, there's certain areas, and we'll work collaboratively and create a feasible plan, and you'll leave us alone, right? And that worked. And so you can see where location intelligence drove that response. So this one was scenario analysis. Where are all of the non-compliant school districts? So what I just walked you through were some case studies and some strategies and patterns on how we grew into an urban analytics-driven office. And when we think about smart city thinking, what comes to mind for me, especially for New York City and all cities, is that cities become smarter by using data better. Thank you very much.